Hi, my name is Taylor Kim. I'm from grade 11 and I did prototyping, initial build, and calculations.
Hi, my name is Rashab Sareen and I did the graphical user interface for the controller and the final build.
Hello, my name is Alex Bondarenko. I'm in grade 12. I did the initial design, the programming, and the electrical.
Hi, my name is Theodore Mihai. I'm in grade 11 and I did the controller and the final build for the robot.
Hi, my name is Julie and I'm from grade 11 and I was responsible for graphic design, initial build, and prototyping.
So we were trying to find a drivetrain that would be fast and efficient as well as difficult to build from a design and robot standpoint, and that would also have many real-world applications. So we were looking online and we found this really old 1930s magazine that contains something called a hog drive, which stands for a hemispherical omnidirectional gimbal drive. So what this permits is that the motor spins at a constant velocity, whereas what actually changes is the direction that torque is applied in, which permits you to change direction very quickly without changing your speed. So we kind of took this idea and made it our own.
These are the servo positions utilized to go front, back, left, and right. Here's front, here's back, here's left, here's right. Here is a demonstration of the robot in action. So, the TopBot is based on an old idea called the Hemispherical Omni-Directional Gimbal Drive, also known as a hog drive. The way it works is you have a high-speed motor, such as this airplane motor, with a hemisphere at the end, or in this case a ball. And when this ball is facing the ground vertically like this, and is rotating, there is no torque. But when it's mounted on a gimbal, like this one, which allows it to change angle in 2 axes, it can tilt and change the contact area from the tip to any point on the ball. What this allows us to do is literally vector torque in any direction we please by varying the angles of the gimbal. The advantages of the TopBot's drive system are that it incorporates the steering, engine, and transmission all into one package. The other advantage of this setup is that you don't have to change the speed of the motors to change the direction. Like, for example, in a car, to change from backwards to forwards, you have to stop and then reverse. With the TopBot, all you do is you just change the angles of the motors, and the torque is reversed. No need for change in speed.
The applications of the TopBot can be seen in environments where you have a flat surface where you need to drive vehicles on. This can be seen in factories or warehouses. An example of this would be forklifts. Traditional holonomic forklift drive systems use mechanism or any other omnidirectional wheel. However, these wheels are very complicated, require a lot of components, and can get gummed up with dirt and debris. This eliminates this because all you have is a ball touching the surface. It's a smooth surface that cannot get jammed up in any sort of fashion. It also allows for omnidirectional drive, which can already be seen in these forklifts.
So this is the controller we built from scratch for our robot. It was built from a plastic electronic casing, and it's controlled by an Arduino FiO and powered by a lithium polymer battery. It's powering the 2 joysticks and LCD screen you see there.
The screen is made by a company called 4D Systems. It runs their own programming language called 4DGL. All the graphics you see on screen right now are coded completely from scratch, and it's getting all the values and data from the FiO via a serial link. This diagram lays out communication and power distribution for the entire project. Serial communication is done wirelessly using XBs between the Arduino Mega in the robot and the Arduino FiO in the controller. The FiO communicates with the microcontroller on the display via a wired connection. In a nutshell, the robot is controlled by the controller and its transmission of joystick positions, which are translated to servo movements by the robot. The robot can also send data to the controller upon request. Such points of data include gyro position, accelerometer data, servo positions, current, and voltage. The screen is able to display all of this data, along with joystick positions.
For controlling the robot's gimbals, we created our own custom Arduino library to contain all the necessary controls for a gimbal. This library controls all the functions for the servos, allowing us to streamline the overall robot code. It has functions for enabling and disabling the gimbal, as well as calculating and setting the servo angles to achieve the desired torque vectoring for directing the robot's motion.